everyone. Today we are going to solve the first internal paper of data science. Our question scenario is following table presents a training set D of class labeled tuples, namely randomly selected from the all electronics customer database. The class label uh, attribute have computer has two distinct values, namely yes, no. Therefore, there are two distinct classes. Let us m equals to if class C1 corresponding to yes and class C2 corresponds to no. There are 9 tuples of class yes and 5 tuples of class no. A root node n can be created for the tuples D. So our first question is find the splitting criterion for these tuples using computation of information gain of each attribute. Our second question is find the splitting criterion for these tuple using Gini index of each attribute, construct a decision tree. And third is construct decision tree of both the cases, question 1 and 2, and compare the generated roots. So this is our table which you have to use. First we have to split criteria for this tuple using computation of information gain for each attribute. Okay, so we know that our formula for entropy is sigma minus pi log base to pi, where pi is the probability of event happening. There are two classes, and so m equals to 2, and this is a case of before splitting. There are 5 no cases and 9 yes cases. So our entropy before splitting will be minus 5 by 14 log base 2 5 by 14 and minus 9 by 14 log base 2 9 by 14. Our entropy before splitting will be 0.37, and now we have to split it according to attributes. So the first attribute is age. In age there are 3 classes: youth, middle age, and senior. And first we have to calculate for class no. So in youth we have 3 no's, in middle age we have 0 no's, and senior we have 2 no's. So our entropy for no will be 0.28, and similarly we have to calculate for yes, and this will be 0.45. Now we have to calculate the weighted attribute, so that will be around 0.38. For that we have to use the weight of each class for no and yes. Similarly, we have to repeat the same process for other attributes like income, credit, and student, and then we have to create the information gain table. These are the entropy before split, and this is the entropies of after split of each attribute. When we subtract this from before split, we'll get the information gain. And in this the age attribute will have the smallest information gain, so age will be our root node, and from age there are 3 possible choices: middle age, youth, and senior. And as middle age is terminating, will terminate it, and for student and credit we'll repeat the same process, like we'll again create the table and we'll see how the decision tree will be formed. Our next question 2, was we have to split criteria for this tuple using Gini index. So our formula for Gini index is 1 minus sigma pi square, where again pi is the probability of event happening, and so we again have 5 in no cases, 9 in yes cases, and the probability of no will be 5 by 14 and probability of yes will be 9 by 14. and Gini index will be around 0.46. This is the case of before splitting, and then we'll split it according to attributes. For age, our Gini index will be 0.48. Uh, 0.58, and similarly for income, our Gini index will be weighted Gini index will be 0.69. Similarly, we will have for credit, which will be 0.46, for student which will be 0.39, and then again we'll use information gain, that is we'll subtract the Gini index values of before split and after split, and we'll compare them to make the decision tree. By this we'll get the root node of age, which is again having three classes of middle age, youth, and senior, and the middle age is terminating. And then we'll uh, again make the table, but this time we'll remove all the entries which have middle age, and then we'll again calculate the Gini index for each one. Similarly for, and we'll repeat the whole process again and again until we conclude our decision tree. So this was our first paper, and this is the solution of our first paper. Thank you for watching.